What functional groups are present there? An alkene. Well, we would not call it an alkane if there's a double bond in the molecule. So the whole thing, we could say there's an alkene in there. But there's no alkyne. Alkynes are triple bonds. Carbon-carbon triple bonds. So we've already said that this one right here is an alkene, that part. But this piece right there, what's that? That is called an aldehyde. Okay, so class, how many carbons are in this molecule? 6? 7? Anyone want us to go 8? No? We're speaking, this is organic chemistry, which is learning a new language. So we want to all get to the point where we all can say the same answer, right? So let's count carbons. I'll highlight those in green. Okay? 1, 2, 3, 4, 5, 6, 7 carbons. Okay? So if there's 7 carbons, how many hydrogens are there? 12? 13? Okay, so I'm going to violate my own rule here just for speed's sake, okay? I'm going to draw hydrogens with just blue lines, okay? Just to go quick. Okay? So, how many blue ticks do we put on this one right here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? Does that make sense? So why don't we have any hydrogens on this carbon right here? There's already 4 bonds. We have 1 bond, 2, 3, and then 4. So there is in fact only... So if we wanted to write the molecular formula, we would say C7H12, 1 oxygen. Perfect. Okay, this next one here. This one would be an alkyne because it has a carbon-carbon triple bond. But we have an alkyne, but what other functional group do we have? A ketone. And the generic structure of a ketone looks like what? We have an R like so. That is a generic description of a ketone. And if you haven't gotten to the functional groups video quite yet, then it's okay. You'll get there over the weekend. But you notice, many people will say, hey, that's what a ketone looks like. That's what they'll put on a flashcard. And then they'll come to an exam looking like this and be like, I don't know what a ketone is anymore. You have to understand what those R groups represent. They represent stuff I don't want to draw. Okay? It just represents carbon, something else. So we'll talk more about functional groups later. But how many carbons did you guys count in this molecule here? 5? 6? Let's count them. 1, 2, 3, 4, 5, 6. Now, do we need to draw that out with a Lewis structure to help make sense of that? 1, 2, 3, 4, 5, and 6. So let's draw carbon 1. We have a CH3, which is bonded to a C double bonded O. And that's bonded to a CH2, and which is bonded to a... So let's just keep track of the numbers here. That's carbon 1, 2, 3. Carbon 3 is attached to carbon 4. Okay. And then we are attached to carbon 5, which is triply bonded to carbon 6. And then what else is attached to carbon 6? We have the hydrogen that's not shown. So you can You could draw this structure as is, like I gave it to you, and that's 100% correct. But you need to realize that if you want to draw the hydrogen, you would have to extend out that bond and draw the hydrogen. So how many carbons do we have? I said C6, and how many hydrogens? Now let's go back to, let's not use the Lewis structure there. Let's use the zigzag. There's 1, 2, 3, 4, 5, 6, 7, 8. Am I missing any? Is there any hydrogens on carbon 2? No, because it already has 4 bonds. So what did I say, 8? And then what else do we have to add to make that chemical formula complete? An O. Okay. Now this alkyne that we just drew here, is that an internal or a terminal alkyne? That's a terminal. It's on the very end. This one, on the other hand, this alkyne right there, is what? That's internal. It's sandwiched in between 2 R groups. So the generic structure for a terminal would be like this. All right, like that. We have these 2 carbons that form that triple bond, and then the R group can be something carbon. And then terminal means that we have to have a hydrogen on the end. But if we have something that looks like this, where that is not hydrogen and is carbon, that triple bond is sandwiched between 2 carbon atoms. Hence, it's going to be an internal alkyne. And that's what we have right here. Because what do we have that's not really shown until you, not explicitly shown? We have a CH3 right there. That's what that line right here represents. It represents a carbon. A carbon. Carbon, carbon, carbon. So how many is that? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 carbons. And so then how many hydrogens do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so if we complete the molecular formula, we have H11, and then we go NO. We have 1 nitrogen and 1 oxygen. Oh, wait. We have 2. All right. So when we take a look at this molecule here, if we clean it up a little bit, all right, clean it up there, what functional groups are present? Well, we've already said that guy right there is an alkyne. This guy right here, that's a ketone, because you see how it has 2 carbons directly attached to it? That's a ketone. And then what is this guy called? That is called an amide. So you can see here, the textbook is only giving you generic structures for these functional groups. You got to think outside of the box. Just writing those on a flashcard is going to do you no good unless you know how to interpret what it's talking about. So I'm going to, like on the exam, I'm not going to give you a really simple, hey, what is this functional group? Like if I draw something like that, you would say that's an amide. But that's it's too straightforward. It's going to be incorporated into a much nastier, well, nasty's not the right word, just molecules that we deal with in everyday life. So they're complex. They're bigger. Okay? So if we take a look, let's see here. Let's do some other examples here. Let's see here. Let's get a lot of practice here. This is just really, really important. Let's do an easier one to start off with here. Now we'll introduce the rings. Okay, taking a look at that molecule there. How many carbons? How many hydrogens? All right. So let's highlight carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we need to, you're so used to in general chemistry drawing the Lewis structures where you just draw all the atoms out and draw the bonds. And that's kind of what you're used to right now. You've got to shift gears and get used to skeletal structures. That this needs to just become second nature. That you see it and you know how many hydrogens there are, how many carbons, so you know what's going on. Okay? So let's do a little bit more complicated one. I'll have you guys do this one. And I'm having a hard time trying to get this file into this OneNote. I can't figure it out right now, so I'm forced to draw them, okay? So this one's a little bit bigger. How many carbons, how many hydrogens? Okay, let's work with that. Cara.
Yes.
Okay. I circled this stupid thing. I want to copy and paste it.
Why am I like the technological one
Because
here?
you know how to work Ditto.
But like not actually.
So you just like hold it, like
Right.
press it.
Oh.
Like-
Okay, hold on.
Like hold it and move it.
No, but it's just gonna. Oh, that just moved
Okay,
it.
never mind.
No.
They're-
Trust.
But they're trying to view it.
Okay.
That's-
All right. Can you not just write it on a paper while we figure it out here?
I'll just read it off. Technology.
You should use good notes. Everyone knows how to do
Stephanie.
But you would. I think it's a lot easier than OneNote,
I
personally.
agree. Oh. You're welcome.
Professor. Like that's me.
Okay, I'm going to add another layer. Your expressions be yay, learning. Thank you. I want to know the hybridization states of all those atoms. You haven't counted them yet? Is that what I heard?
There's so many lines.
Yeah, there are a lot of lines. So, how many carbons, how many hydrogens, and what are the hybridization states of all these atoms?
I mean, it depends, but like. Um, if you have just carbon with bonds with a hybrid, right? So if you have carbon with bonds. I'm sorry. If you have carbon with two bonds instead of three, and then you have a double bond. Right. So if you have carbon with three bonds.
I guess you can.
Yeah, so that's like the short side. That goes for like carbon, as well. Literally anything you have in here. Yeah. Based on the which one?
Down here?
So how we feeling? Do we need more time?
I'm done with that, thank God. It was the worst lap of my life. No, I'm kidding. I lied. It wasn't that bad. I did it last week. But I didn't like that. No, I just didn't like my team. And like I think that makes such a really big difference on like your experience. The lab is accuracy based, and so well like as much as it can be, so we're quick on our gels. Like sometimes, like it was the first time I had ever made like a data She TAs this semester. I know she does. So, yeah. But Kyra and I are doing the Orgo 2 lab together. Like participating. Enrolled in. Students.
Okay, do you guys need more time? Okay, so what you have found, you will see on your Canvas page a assignment that says January 9th. How many carbons? I need you to take a picture of your work that you've done so far and upload it right now. Okay? On this specific? On this problem. All the questions that I asked you. How many carbons? How many hydrogens? And I said, what's the hybridization states of all the atoms? I want you to take a picture of your work and upload that right now. And we're going to go after that. So I'll give you guys a minute to take the picture, put up what you have. If you're not complete, I don't care. I want you to upload it right now. Upload what you have. We're going to go over it. Yes? Just this molecule, guys. Just this one. Yeah.
How do you want the hybridization states listed?
I don't care. Just do it however it works for you and what you've done. There's no time to redraw it and rewrite it because I said stop working on it, take a picture, upload it. If it takes 2 pictures, so be it. Just get me the information onto that link.
Yeah. That's what I was saying.
Then we'll go over it.
Like, that's where I was going with it. Or like, just like, no. Maybe it's a birthday gift.
And if we have if it's bogged down because of so many people trying to log in and do this, then the due date to get this uploaded, I give you like a 10-minute grace period after class, okay? So you'll have time to do that if you're having trouble logging in. Class, what problems are we supposed to upload? More than that one? Just that one. And I've already gave you a minute to do that, so if technology's working for you, then you should be done. If not, then you have a few minutes after class to get that uploaded. Make sure it worked. If you say you uploaded it, but there was some error and it didn't get uploaded, that's on you. You need to make sure it worked. If it did not work and you come to me 5 hours later and say, I just realized it didn't work, can I get full points? The answer is no. You will have a late penalty assessed to it. It's on you guys to make sure things are working. Now, when technology throws a wrench in plans, I will work with you. Okay? We will make some accommodations to figure it out. But it is really your responsibility to make sure things are turned in. Okay, so let's count carbons. That's the easy part. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. If we count hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Now, hybridization states. Once you guys can figure out and see how many hydrogens or how many bonds there are, then you guys all humbug, like, oh, I have to figure out hybridization states. That's so hard. No, it's not. Can you count to 4? Yes. Then count to 4. Okay, so if we go to this one, let's do it in purple here. What's the hybridization state of that carbon? How many bonds are there? 4, sp3. Right? This carbon right there, how many electron groups? There's 1, 2, 3. So that's sp2. It's really that straightforward. What about that oxygen atom? What's its hybridization state? sp2 as well, because what's not shown? 2 lone pairs. In order for that oxygen atom to be neutral and have no formal charge, it has to have an octet, okay, which it does, and it has the 2 lone pairs. So that's sp2. Quick and easy. Now, what about this guy, this carbon right there? What's that hybridization state? That's sp2 because it has 3 groups. Okay, this carbon right there has 1, 2, 3 groups. Do you see that? So that's sp2. Pretty quick and easy. So all those carbons in that ring are sp2 hybridized. Anyone know the name of that ring? That's a benzene. Okay? And how else can I represent a benzene molecule? Because organic chemists we do line structures and zigzags to make things fast and easy. If I want to describe a benzene, I'll just draw a circle. Okay, just like that. So that means it could look like that. Is there any difference between me alternating those double bonds and putting it like this? No, it's the same thing. That's why I just do the freaking circle. Okay, because there's 2 versions. Those pi bonds move around. So we just represent it with a circle there. What would be the hybridization state for that carbon? sp. It has 2 groups around it. So that's sp. What about this carbon? sp as well. It has 2 groups around it. Okay? And then if we did not know that there was a hydrogen there on that aldehyde, this is a common mistake people will make. They will look at this carbon right here, and they will be like, oh, Dr. Lawrence says just count how many electron groups. There's 1, 2. That's clearly an sp hybridized carbon. Why is that wrong? Because they failed to see that there's a hydrogen right there, which is the 3rd electron group. So that carbon would be, well, sp2. You see how important it is to keep track of where your hydrogens are? It's also super critical that you understand where your lone pairs are, because they may or may not be shown. But if you're given a molecule and you know the formal charge, then you can figure out how many lone pairs there are. And that's what the next class period is going to focus on, is making sure we remember formal charges and how to calculate those. Now, you may be like, well, why do I need to understand these things? It's because later on in the semester, we're going to learn about reactions. And you are going to be given reagents, and you just throw them together, and then you need to figure out how these reagents react. And one way that you can get a good hint as to know how a reaction is going to work is by finding their formal charges. If you know the formal charges, then you can predict reactivity. And it's really this simple, class. If you have a formal charge of -1 and +1, what do opposites do? They attract. So there's going to be a reaction. Okay, I'm still talking. But if you look at these 2 molecules and you have no idea what the formal charges are, how would you figure out that they could react? So that's the main importance here of being able to do formal charges and whatnot. So let's just finish this up. What's the formal charge of that oxygen atom? That's sp2. Okay? Any questions on how I'm doing that? No? Let's see here. Okay, so another thing that you need to be aware of and you have to pay attention to the verbiage of what the question is asking. Okay? So for example, what have we been doing this whole time? How many carbons? How many hydrogens? And I could give you a problem that looks like this. Let's say problem 1, and it says how many carbons are there? Okay? And you do that wonderfully. And then the next problem, I say how many atoms are there? But you guys have already been in the mindset, oh, carbons, and then I'm supposed to count hydrogens. But what did the question actually ask? How many atoms? So what does that mean? All of it. How many atoms there are. Okay? So you just have to pay very close attention to what the question is asking. And this is a skill that's necessary for your future employment. Okay? Paying attention to the details. Because I know I will have this argument. Dr. Lawrence, I know how to calculate how many hydrogens there are, but I just misread the question and didn't answer it according to that. I'm like, it's great that you understand how to do that problem, but maybe I was just assessing, are you paying attention to the details? Okay? Because that's something very important. Let's just look at a drastic example. You know how many people have had limbs amputated, but they've amputated the wrong one? Because people, was it the left arm or the right arm? Okay? Pay attention to the details. Okay, so are there any last minute questions now when I open it up? Guys, please be quiet and let's listen if there's any questions. Question. So can a molecule have more than one functional group was his question. Can you answer that by yourself? What have we just been doing? Did I not show you a molecule with a double bond and an aldehyde? Or a triple? Yeah, it can have as many functional groups as possible. That's a really good question. According to that clock, I still have 3 minutes, right? Okay. Does methyl what? Does methyl count as a functional group? Not really. It's just a name that describes that type of alkane. Okay, what you're going to learn is that we have alkanes, which is just carbon and hydrogen.